and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the determination of centroid for composite sections. The course outcome of today's session would be identify the centroid and center of gravity for the simple and composite plane sections from the first principles. The topic covered would be determination of centroid for composite sections. Topic learning outcome is understand the concept of centroid and center of gravity involved in practical engineering problems. First, let us understand how the composite figure or composite section would look like. Let us say a composite section is a mixture of two or more shapes given in a single system. Like you can observe here, in this lamina, the two-dimensional lamina, this is a rectangle which is of one part, and this is a square which is of another part, and this is a triangle which are mixed all together, and it is consisting of a single section, or it is seen as a single section. So such type of complicated problems or such type of complicated sections, what we will do and how the procedure would be for identifying the centroid, we will be seeing today. The geometric decomposition is one of the techniques used in obtaining the centroid of a compound shape. As we have discussed, a compound shape is a shape which involves two or more shapes together at a time. And it is widely used method because the computations are simple and requires only basic mathematical principles. It is called geometric decomposition because the calculation comprises decomposing the figure into simple geometric figures. That is, as we have seen in the previous example, number of shapes, regular shapes will be divided. For a given single shape, for a given single lamina consisting of two or more regular shapes, we will be dividing the whole section into two or more, whatever number required for getting the regular laminas will be divided. In geometric decomposition, dividing the complex figure is the fundamental step in calculating the centroid. Now let us see the step-by-step procedure in solving for the centroid of compound shapes. So the first step would be divide the given compound shape into various primary figures. The primary figures like regular, rectangle, square, triangle, the known shapes. It may be a pyramid, it may be a rhombus, anything which is having a known shape, it would be divided. These basic figures include rectangles, circles, semicircles, triangles, and many more. Where we do know the centroid's position for these regular shapes, we will be dividing the given compound shape into regular shapes. In dividing the compound figure, include parts with holes. Like if at all a compound section is given like this and there is a hole present here. Okay, this is the material, this is the place where the material is present, and here there is no material. So what we will do, we will be dividing this whole compound shape. This is a compound shape having one rectangle and one circle. So we will be combining these two also. Even though there is a hole present, we will be considering that hole also as a regular shape or as a regular circle. These holes are to treat as solid components yet negative values. Like we will be subtracting the value from the whole material that is present. Make sure that you break down every part of the compound shape before proceeding to the next step. Right? Total section, total given lamina compound shape should be divided. Then solve for the area of each divided figure. So first we will be solving the areas of each divided figure. After determining the area, designate a name like area 1, area 2 and area 3 for the divided shapes of 1, 2 and 3 respectively to each area. Make the area negative for designated areas that act as holes, right? That means we will be considering minus A, minus area for the holes which we will be remaining reversed. The given figure should have an x-axis and y-axis, right? The reference axis. The initial step, what you need to do is you have to fix the reference axis for identifying the centroid. The coordinates which we are going to take as the end result should be with respect to the reference axis. So the x-axis and y-axis should be previously predefined. If x and y axis are missing, draw the axis in the most convenient means, right? If at all in the problem, the x and y axis are given in the problem itself, then it is okay. But if they are not given, take a convenient axis, convenient reference line as the axis. Remember that x-axis is the horizontal axis while the y-axis is the vertical axis. You can position your axis in the middle, left or right, depending upon the convenience. Okay, you can place your vertical axis to the extreme right, and you can calculate the values in the negative way, or you can place the y-axis, vertical axis, in an extreme left position, where you can do the problems in a positive axis manner. And then it depends everything on your convenience of calculation. Get the distance of the centroid of each divided primary figure from the x-axis and y-axis. Okay, you need to identify the each divided figure's centroid's distance from x and y-axis, your selected reference axis. Then, creating a table always makes computations easier. Plot a table like the one below, like area of each individual figure and total area, whereas the x-axis and y-axis and areas of first divided section, regular section, second divided regular section, and so on. All these things you can maintain a table so that it would be easy to substitute all the values in the given formula. Then multiply the area A of each basic shape by the distance of the centroids x from the y-axis. Then get the summation of sigma ax. Okay, you need to multiply the area into the distance of the centroids from the x and y-axis. Then multiply the area A of each basic shape by the distance of the centroids from y-axis. Okay, distance of centroids y from the x-axis. Then get the summation sigma ay. After that, solve for the total area, that is sigma A of the whole figure. Then solve for the centroid Cx. Okay, Cx is the centroid of the position of the centroid from the x-axis, right? The whole figure by dividing the summation sigma ax by the total area of the figure E, sigma A. The resulting answer is the distance of the entire figure centroid from the y-axis. Then solve the centroid Cy of the whole figure by dividing the summation sigma ay by the total area of the figure sigma A. The resulting answer is the distance of the entire figure centroid from the x-axis. This is how you will be calculating the centroid of the complicated shape. You will be learning how to calculate the centroid of the compound sections or compound laminas while we solve the problem. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.